Good afternoon.
Good afternoon.
Okay, let's start. Dear participants, welcome to the third part of the student session. I remind you about the time limit, 5 minutes for presenting the results and 5 minutes for answering questions. And we start with the presentation. The approach to creating the recommendation system of piano pieces, and the speaker is Maiia Holshtein, please.
Thank you. Please let me share my screen. Do you see my screen?
Yeah, we see it.
And now, yes? Okay. Good afternoon, dear audience. I am glad to present you my study, The Approach to Creating the Recommendation System of Piano Pieces. Nowadays, a lot of descriptions of piano pieces can be found in internet or in specialized collections. Since there is no special recommendation system for pieces of music, the purpose of this study is developing of the algorithm of providing recommendations about piano pieces by their difficulty levels. Recommender system is one of the classes of machine learning algorithms that offers a user relevant samples. The main problems of recommendation systems are cold start problem, filter bubbles, problem of sparse data, fraud, and synonymy. The other problems are presented on the slide. Our recommendation system was developed on the base of corpus of descriptions of 75 piano pieces, usually an indicator of complexity of pieces of musical art can be presented in 2 or 3 words. So bigrams and trigrams from given corpus were separated for further work. There was used statistical method PMI to search for collocations, as it's well suited for work with terms. Pointwise mutual information is a measure of connectivity that is used in theory of information and statistics. The formula of PMI, where W is the main word and W1 is a context routine, is presented on the slide. The description of PMI method is also presented on the slide. As an example, 1,000 bigrams and 1,000 trigrams from given corpus were taken. As a result, the following bigrams and trigrams were obtained. For example, Pergunt, Blossom Tremulous, and Johann Pachelbel. Bigrams and trigrams suited for indication the difficulty level from these collocations were selected. For example, contain obligatory competent students, considerable talents, and keyboardist acrobatic skills. Thus, according to the formula, the precision of PMI method was evaluated as 14 and 37%. At the moment, there have been created the corpus of 75 descriptions of piano pieces, separated bigrams and trigrams for determining the difficulty level by existence of certain collocation in description of certain composition, determined 4 difficulty levels for classification of the pieces of musical art, and referred pieces of music to the corresponding difficulty levels. The example of distribution, the collocations by difficulty levels is presented on the slide. Thus, we have checked all the descriptions and obtained the following results that are presented on the slide. The main problems during developing of the recommendation system the dataset in the corpus, as there is no special collections of descriptions of technical execution of the piano pieces. Synonymy, as these texts were written by different authors in different styles and with different purposes, and using collocation separately from the context because the problem of accuracy of determining the difficulty level appeared. In the future, it plans to consider collocations in the context, create a test set of piano pieces, and evaluate the precision of developed recommendation system work. Thank you for your attention.
Thank you, Maiia. Dear colleagues, ask your questions, please.
Okay, I have some questions to Maiia. The first one, who will be the user of your recommendation system?
Okay, thank you for the question. The users of my recommendation system can be pupils of primary or secondary schools, or their parents whose experience isn't enough for determine the difficulty level by scores, not scores.
Thank you. And are you planning to develop the user interface for your future program?
Yes, of course, interface will be developed to make the search of users easier.
Okay, and could you please return to slide number 8? Number 8.
With the precision.
This score that you received, is it low or high, or I don't know?
Okay, so, the precision in given occasion is a relation of number of correctly separated collocations. In given occasion, the collocations indicating on difficulty levels of piano pieces to the number of collocations resulted from PMI method. For me, the main purpose was not only to find musical terms, but special collocations indicating on difficulty levels. And I separated such collocations by myself because I have 16 years experience in playing the piano, and I am late intermediate pianist. And due to a high specialty of these collocations, the number of them was significantly lower than the number of collocations simply referred to musical terms. And as for score, consider our subject area, I would like to say that it isn't so low.
Okay, thank you very much.
Thank you.
Thank you. So other questions? Valeriia?
I have one. Can you please tell, will you rank the list of the results that you obtained?
Thank you for the question. Yes, I will rank the results. I'm going to estimate the complexity of the composition in scores. Each difficulty level will be assigned a grade, and when the collocation is found in the description, the composition is assigned a score. If description contains 2 or more collocations, the assignment of collocations will be summed up, the scores will be summed up, and then the compositions in each level will be presented by ascending scores or by ascending complexity.
Got it. Thank you.
Thank you very much.
Thank you, Maiia. And
oh, sorry.
Please, turn off your screen, your presentation.
Thank you very much.
And the next presentation is implementation of the Riemann homonymy by collocation system. The speaker is Anastasiia Khluieva, please. Thank you.
Please let me know if everything is okay and you can clearly see everything on the screen.
Yeah, we're here and see the presentation.
Thank you. So good afternoon, everyone. My name is Anastasiia Khluieva, and me and my tutor Zoia Kochuieva and Natalia Borysova would like to represent our research implementation of removing homonymy by collocation system. Modern intellectual systems do not process text and natural resources with a high sufficient quality due to the presence of such a linguistic phenomenon as homonymy. This concept is marked by ambiguity of approaches to its study and, in fact, interpretations. This has caused a relentless interest on the part of linguists. Homonymy is a difficult phenomenon. It has many aspects that require comprehensive analysis. Thus, the purpose of this work is to develop a system for removing homonymy using the method of collocations. To achieve this goal, we have the concept of homonymy as a linguistic phenomenon, its types and problems of origin, as well as possible method of removing homonymy. The subject of the study is the removal of homonymy by using the method of collocations. To solve this problem, the following tasks were formulated. The first one, performing an analytical review of the literature and the topic of homonymy, its types, problems that arise for its removal, and methods for eliminating this problem. And the second, development of an algorithm for removing homonymy by collocation. To get started, let's introduce the concept of homonymy and its feature. Homonymy is a synchronous phenomenon in terminology, which is based on the absence of common sum in the meanings of the same terms of expression and commonly used words, terms of one or more related or unrelated areas of knowledge and human activity. There is also different types of homonymy, and highlighted one, grammatical, were chosen for our research. Among the grammatical homonymy, there are homoforms, homographs, and homophones. Homoforms are morphological homonyms that are distinguished on the basis of sound coincidence and the same spelling of words form belonging to different lexical and grammatical classes or different forms of the same word. Precisely this type is an object of our study. Historically, almost all methods of removing homonymy are divided into two groups, which are represented on the slides. All these methods have both advantages and disadvantages, so it was made a decision to develop hybrid method of homonymy removing by collocation system. So, collocations are compounds of words. The probability of using which together is greater than probability of using these words separately from each other. Precisely because these compounds are usually stable, they need a certain form of words to match each other, which can help with the removal of homonymy. Based on the result of analysis of sources of the problem of homonymy, namely the emergence of incomplete grammatical homonyms, among homonymy pairs of words, homonymy with the noun most often occurs, so we take collocation with nouns to remove homonymy. Among the above types of collocation in the language, collocations such as adjective plus noun and preposition plus noun are most often used, and we will take such collocations for our research. There are homonymous pairs of adjective plus noun type. To get the most commonly used context with these pairs, the sketch engine platform was used. There is a context for a word from a text in Ukrainian language with a volume of more than 2 billion words. There are 206 collocations of adjective and noun. The second type of collocation is based on the frequency dictionary of collocations. Only collocation with a frequency of more than 30 cases per 1 million words are represented in this research. In this study, the word isn't reduced to the lemma because the study of homoforms requires exactly the form in which the problem of homonymy arises. Therefore, the collocation database will use the form of the word in which difficulties arise, with the appropriate context of comparison directly with the form of the word used in the sentence. Hence, on the basis of the revealed sequences, we created particular algorithm of word. The first step, the user enters text in the interface window, then text goes through the tagging process. The second step, the program checks whether the preposition with the context is contained in our database. Its tag changes to the one specified in the database as long as a match is found. The third step, the program checks whether the noun is contained in the context of the adjective from the database. If the match is found, its tag changes to the one specified in the database. The step number 4 is thus a result, the program reduces text with assigned part of speech to each word. The user receives standard tag text provided there is no matches found in the database. This slide demonstrates in which way the collocation bases for each particular type were created. There are pairs of words with already marked correct tag. The total amount of collocation is 821 construction. There is example of work. As shown in presentation, the pairs of words, part of speech of which were changed, are surrounded by curly braces. During the research, it was performed an analytical review of the literature on the topic of homonymy, its types, problem that arise for its removal, and methods for eliminating this problem. Algorithm for removing homonymy by collocation was created. System for removing homonymy using the method of collocations were developed. Given method and algorithm can be easily extended for usage of noun and not only, and continue to increase the base of collocations for Ukrainian language. Thank you for your time.
Thank you. So questions, please.
Okay, Nastya, very interesting work. Could you say, please, in which case can your program be used, for example? And I have one more question after that.
As it was mentioned earlier in this study, we have worked with a grammatical homonymy, especially with the homoforms. So in cases when homonymy occurs in homoforms, it will be useful. I can show as a result in the result of our program product work. For example, there is a expression like ridna mate, but mate not always can be noun, but sometimes it can be form of the verb. So when it happens, and for example, in cases when we need to have a text, and it should be precisely correct, then in case we can use our work.
Thanks. And do you see same work to Ukrainian language, or your work is special?
You mean like, do we have similar works or not?
For example, yes, yeah.
I guess that there are a lot of works which are connected with collocation for Ukrainian language, especially if we speak about the second type of collocation in our study. They are preposition plus noun. And there is also a vocabulary in open source vocabulary on Mova.info website, which is created for collocations, but not only preposition collocation. So I can say that collocations for Ukrainian language are interested, but maybe removing homonymy by collocation is a new way in study of ambiguity and homonymy removing.
Okay, thanks.
Thank you. Other questions?
Yes, I also have a question. Thank you for your interesting report. And why did you choose the method of collocations in your study?
As it was mentioned earlier, we have checked method based on rules and also a statistic based method, but both of them has both also advantages and disadvantages. For example, method based on rules takes a lot of time to create and a lot of resources, and vice versa, the statistic method are not so precise. So it was made a decision to create a hybrid method in the view of collocation system creation.
I see, thank you.
Other questions, please? Then I will ask, have you considered to identify more than 2 word combinations to remove homonymy?
like preliminary research, no, we chose only 2 parts, which are the most often occurs, like the most frequent one. But if you speak for the further, of course, it can be possible to continue study the research in case of verb plus noun collocations or noun plus noun collocations.
Yeah, thank you. So we go on. And the next presentation is special aspects of translation of medical instructions. And the speaker is Vladyslav Khramtsov.
Yes, hello. Maiia, can you show the screen?
Yes, of course. One moment.
Thank you. Okay, good afternoon, dear audience. I would like to introduce our research. The topic is special aspects of medical instruction translation. As you already know, today's presentation is designed to present some important points of translation. On the next slide, I will begin with an overview of the purpose, object, and subject of the study. The purpose of the study is to convey the content accurately as much as possible to preserve the feature of the study, of the style, and the object of the study is a structural analysis of the studied terminological units in the medical field. The subject of the study is a corpus of an English language medical manual for contact lenses. So on the next slide, we can see difficulties we have encouraged during the study. The main lexicogrammatical difficulties in the course of our analysis, we single out the following. The presence of a significant percentage of so-called false friends of the translator, justified use of transcription or transliteration in previous Ukrainian language translation, and some differences between the grammatical structure of the sentences in English and Ukrainian, affecting the shift in the logical emphasis of the sentence. And also the need to apply the technique of addition or semantic development is possible in many cases only if the translator has some special information. On the next slide, we can see our self-assembled corpus with the medical text and instructions. The material of the research was medical text in English, the analysis of which allowed us to reveal general patterns and tendencies of the wide English medical space. We reviewed lexicosynthetic peculiarities of medical text in English, and we found out the following peculiarities. Both English and Ukrainian terminology of medicine and healthcare show the advantage of the big component terms. This can be explained by the fact that they meet such most important requirements for the term as simplicity and conservation of language power. On the next slide, this is a structural analysis of the studied terminological units in the field of medicine and healthcare. Show that according to the ratio of the number of components among them stand out. Single component terms, 2 component terms, and 3 component terms. Even a superficial analysis reveals significant dominance of the 2 component terms in medicine. Therefore, the preference of 2 components over 1 component terms can be explained by the fact that 2 component terms better meet one of the most important requirements for a term, its brevity. So the preference of 2 component terms over 3 component terms can be explained by the fact that they save speech effort. On the next slide, another important type of the word combination terms is eponym. An eponym is a term that contains a proper name as well as a common name for a scientific concept. So term eponym can be formed in a non-fixed way from a proper one by metonymic transfer, and they can also be affixal formation from a proper one. During the study of medicine terms of eponym in the scientific literature, we have another encouraged the opinion that eponymic concepts are conveyed in to use and polite medical terminology. The next slide. Here we can see the most common mistake in translation, which our research found the following. Translator false friends, more false friends of translator, total enemy of translator, and mutation in meaning, rare or special meaning. And what about the conclusion? The materials of the study, the next slide, yes, thank you. The materials of the study were medical corpus in English, the analysis of which allowed us to identify common patterns and trends in the broad English language medical space. In the structure of modern medical terminology, an important place belongs to the term and phrases denoting individual concepts of the branch and conveying their complex internal correlation and multi-determination. We have found that one of the most important types of terms is eponym. That is a term that has its composition a proper as well as a common to denote a scientific concept. The next slide, the prospect of research is a terminological system of individual medical branches in comparing and analyzing Ukrainian language equivalent of medical terms in various fields in order to identify terminological homonymy and policy. So thank you for your attention. I hope you found it interesting. If you have any question, I will be happy to answer.
Thank you, Vladyslav. Dear colleagues, your questions, please.
Okay, we have some question. I think, Vlad, thanks for telling. Could you say, please, what is the main advantage between one component terms over others?
Okay, thank you for your question. I think that the most important advantage is that this term of this type save speech effort, thus they make the dialogue more understandable and not so meaningful. And when we speak about translation, it can save our translator efforts. So for this reason, we should use this one component terms in order to this translation will be more clear. So.
Thanks.
Thank you for the question.
I also have a question. Vladyslav, please tell us, is it possible to avoid lexicogrammatical mistakes during translation of your medical instructions? Is it possible at all?
Yes, thank you for your question. I think yes, but it's very difficult. There are common mistakes such as for friends, mistakes during transcription and transliteration, and and of course some differences between English and Ukrainian grammar structure. So for this reason, we should use maybe some thesaurus in a medical translation, and it will be better. So we can avoid some a pleasure of mistakes.
Maybe some parallel corpuses for medical text or something else to train your translation system or something.
Yes, but it's my research for my diploma work, yes, and I hope that it will be useful for everyone who translate this medical translation.
Yeah, it's very important task. I think. Thank you very much for your answer.
Thank you. Thank you.
Thank you. Other questions?
Yes, I also have a question. Thank you, first of all, thank you for your report and so interesting subject area. I would like to ask what are the consequences of incorrect translations of your instructions, of medical instructions?
So we think that this is so dangerous. The translator in this field, like a doctor, yeah, and so incorrect translation can cost for patients' lives and or at least harm many people who use this product or this pills or drugs. Yeah.
Thank you. Thank you for the answer.
Yeah, thank you.
Thank you. Other questions? No more questions. Thank you, Vladyslav.
May I stop?
Thank you so much.
Yes, ma'am. Please stop the presentation. And the next presentation is linguistic characteristics of combat post-traumatic stress disorder in a trauma-related narrative, computational context-aware approach. And the speaker will be Valeriia Didushok. Please, Valeriia.
Thank you. Hello, everyone. One moment, I'll share screen. As already mentioned, my topic is about linguistic characteristics of combat PTSD and the way how we can figure it and probably detect it with context-aware approach. And actually, before proceeding, I'd like to focus a little on the importance of understanding of connection between language and mental state. This connection is what Copeland called discourse of the unsayable. And in other words, our speech is kind of reflection of our inner knowledge and convictions. And in the case of PTSD, traumatic events affect more than just the mental health of people affected in a traumatic situation, but also their language. And actually, through that language, a traumatized person can transfer their raw experience. Language can actually act both as indicator of how the survivor overcomes traumatic events and allows us to understand how a person experiences the consequences of the trauma. And moreover, language can be a trigger of the trauma, and we can look actually at some biographies and see that connection of traumatic and linguistic experience. For example, Arthur Goldschmidt, who was a child, survived German Nazi. He described actually German language as something that marked by feelings of extreme distress. So even the type that language sounds like actually can be kind of traumatic trigger. And actually, that is why linguistic analysis can help us identify subjective differences between groups of people who have experienced same traumatic events, experience PTSD in different ways, and the result have different effects from the therapies they used. And one of the prominent works in this field was made by Panda Baker. It's Linguistic Inquiry and Word Count. And it actually, linguistics characteristics, according to Panda Baker, are elements of language that relate both to form and context of the text. And form or style refers to clauses or articles, prepositions, negations, and accents used in the text, and the structure of the text as well. While the context is presented using words to describe emotions, thoughts, actions, or sensations. And that is why in our proposed methodology, we use three components: data collection, linguistic analysis, with the help of similar to linguistic inquiry and word count dictionary, and model development. So the data preparation step included data scraping from the PTSD forum. It's a United States-based forum where people can share their emotions and experience through different ways of trauma. And in our research, we used only those that were marked as military. And each topic was passed into a separate file. For this one purpose, we used Selenium WebDriver. And then each file was then manually reviewed to determine if it was personal or general. And the personal one refers to that author of the topic describes his own feelings, calling for help and answers, while general is the answers that the topic author receives as a feedback. And that is actually kind of example of the tags that we scraped from that forum. As we can see, there are pretty full of pain, as it can be seen actually. And that's the result of studied all the data set. It included 51 after manual preparation data text extracted. And we actually studied proportion of descriptive words of negative emotions as an indicator of suppressed feeling, words related to cognitive processes as an indicator of cognitive processing, and words of association with death or religion as indicator of mental lawlessness. We also paid attention to pronouns as an index of self-immerse and verb tense switching. And actually, as for verb tense switching, it can show that sometimes narrator used present focused words and other times they used past focused words that can be seen as a tendency to reflect on the past versus staying in the present moment. And to be more clear, what actually these word categories can presented by and why some words can be in multiple categories. For example, in category of anxiety and sadness and negative emotion preserves word anxiety as well as abandon. And for the cognitive processes words, there are probably words like answer, know, wonder, presume, and so on. And as for difference between focus past and focus present, in that vocabulary we used actually, yes, present tense forms of the verb, and while for focus past is past tenses of our verbs. As for that, there are probably most of words like warframe, grief, drone, disease, corpse, and so on. And that's the result we can...
Please, Valeriia, please complete your presentation. 1 minute left, please.
Yeah, the result we computed descriptive statistics as shown in the table, and that further will be used as kind of triggers for our model. And as for context-dependent classification, as input, actually, BERT accepts two concatenated text segments separated by special tokens, and the length corresponds to the specified maximum. While the original models was pre-trained on a huge data set of untagged text, and it actually assumed that it's, since we use anomaly detection approach as non-anomalous, while input sentence that we use as for detection with the help of that previously distinguished words with specific weights are assumed to be treated as probably anomalous one. And in such a way, anomaly can actually reflect violations that are internal or arising signal that are usual behavior of phenomena. So depending on difference between input text and non-anomalous text, we can compute and see actually.
Valeriia, I'm sorry to interrupt you, but
yeah,
we have no time left. Yeah, so thank you. Thank you very much for your interesting presentation. And so we should end this session. Dear colleagues, dear students and all the participants, we close the student session, and we are grateful to all of you for interesting presentations, for meaningful discussions, and we wish you new successful results in science and studies. Thank you for your participation.
Thank you. Bye.
Thank you very much.
Thank you.
Thank you.
Thank you.
Thank you. Thank you.